Last section we went over parallel lines. I also said it was kind of silly for them to be there, since after introducing them, we never used them again. This is the section where we actually use the parallel lines. This is where they should have been introduced. In the outline you'll see a lot of familiar terms from last time. Same side interior angles, alternate interior angles, alternate exterior angles, and corresponding angles. Last time I showed you they all existed, even if the lines weren't parallel. That's true. But nothing interesting happens until the lines are parallel. In this picture I have angle 1 and angle 2. They are same side interior. Line A and B are parallel. I said nothing interesting happens until the lines are parallel, so here the lines are parallel. What do you suppose is true about angle 1 and angle 2 that makes them interesting? They aren't congruent. Angle 1 is obviously obtuse, and angle 2 is obviously acute. So what is it? How about if I reposition angle 2? Now you can see that angle 2 fits perfectly here. In this position it's easy to see that angle 1 and angle 2 are a linear pair. We know that linear pairs are supplementary, back to the original picture. Even though angle 2 is back where it originally was, it is still supplementary with angle 1, which brings us to the same side interior angles postulate. If a transversal intersects two parallel lines, then the same side interior angles are supplementary. That's the special property of same side interior angles. That's exactly what I just demonstrated. You will notice that like many postulates and theorems, the description is an if-then statement. One postulate done, 3 theorems to go. Now we get to the alternate interior angles theorem. I have 2 transversals drawn below. Each one makes 2 pairs of alternate interior angles. So let's look at all of them now. First we have angle 1 and angle 2. Then angle 3 and angle 4. Now angle 5 and angle 6. Finally angle 7 and angle 8. Here are all 4 pairs of alternate interior angles. What do you notice about each pair? Hopefully you figured out that each pair is congruent. That brings us to the theorem. Once again, it's an if-then statement. Hopefully that makes sense given the picture. Now instead of interior, now we want the alternate exterior angles. Hopefully you can figure those out by yourself, but here they all are. Just like the alternate interior angles, the alternate exterior angles are also congruent. This looks nearly identical to the last theorem. Now on to the last theorem. This one deals with corresponding angles. You should be able to find corresponding angles on your own, but here they are. It should be pretty obvious, but the corresponding angles are also congruent. That's a lot of pieces congruent. Students often get lost with that though. They know one thing isn't congruent, but they can't remember which one. So they just put down that all of them are congruent. That's not right. The same side interior angles are supplementary, not congruent. All of the rest of them, the alternate interior angles, the alternate exterior angles, and the corresponding angles, are all congruent. If you're having a hard time remembering which is which, do a quick sketch of 2 parallel lines in a transversal. Just make sure the transversal has quite a bit of slant to it. If you do that, it is pretty apparent that angle 5 and angle 2 are not congruent. So the same side interior angles are the ones that are not congruent. One final thing. Here we have all of the corresponding angles from the last slide. But we know that the vertical angles are congruent too. Because of that, I can recolor the picture to show that when 2 parallel lines are crossed by a transversal, those 8 angles can be grouped into sets of 4 which are all congruent. Angle 1, angle 7, angle 2, and angle 8 are all congruent. Similarly, angle 3, angle 5, angle 4, and angle 6 are all congruent too.